administration, and extended community who put in time, resources, and a lot of effort to make today happen. Before we begin, and I know we're all excited to begin, I know I am, I'm really anxious, I can't wait to see this happen. I want to remind everyone, our special guests, to make sure that your cell phones are either turned off or on airplane mode. I want to make sure that they don't interfere with any of our live feeds or become a distraction to those around. With that said, I'm going to turn this over to your principal, Mrs. Garman. She has invested countless hours coordinating this event, and I know there's probably no one here that's more excited to see you have this opportunity. So, Mrs. Garman.
Hello, students, staff, and friends of the Bellefonte Area Middle School. We are about to make history at this school as we attempt, for the first time ever, to put bands in space. This project has been a year in the making, and I have to say I am so incredibly proud to stand on this stage as the principal of such an amazing school. This has truly taken a team to make this happen. I want to take a moment to acknowledge some of those team members. First, we need to give a major shout out to the amateur radio team from the Nittany Amateur Radio Club, who built the equipment necessary for us to connect to the International Space Station. Those members include Woody Brent, John Gazar, Greg Miller, Sharon Geisler, Eric Prescott, Mike Coslow, and Bob Spooner. Please join me in a round of applause for their efforts. Next, I would like to thank some of our VIPs and our experts who are joining us today. Senator Jake Foreman, State Representative Carrie Benninghoff, Tammy Emmerman from State Representative Mike Hanna's office, my fellow Bellefonte Area administrators, and our panel of experts, Bill Syrick, Chris Palma, and Jason Nichols. I also want to commend the staff and students of this building. Your enthusiasm is contagious, and your willingness to support at any time helped to bring this event together. I applaud all of you for your effort and for your team spirit today. There were also several school districts from across the state of Pennsylvania who submitted questions for this event. I would like to recognize the following schools for joining our mission. Hershey Middle School from the Hershey School District. South Fayette High School from the South Fayette School District. East High Elementary School and Elizabethtown Middle School from the Elizabethtown School District. Harrison Middle School from the Baldwin-Whitehall School District. Charles Bone Middle School from the Pennsbury School District. Penns Manor Elementary School from the Penns Manor School District. Logan Elementary School from the East Allegheny School District. And Old Forge High School from the Old Forge School District. Thank you for submitting your questions and taking part in this program. We have a full schedule for you and quite a bit to cover before our contact occurs with our astronaut, Mr. Scott Tingle. So, without further ado, I would like to introduce Mr. John Gazar, a member of the Amateur Radio Club, as he directs us on the next path of our journey. Mr. Gazar.
So welcome aboard, and I have to agree with the sentiment of all the enthusiasm that I've seen in this school through the participation photos that have come into us, and looking at the hallways out here. The art class did a great job decorating. Overall, just a really exciting team effort. So with that, we will start with a little video to introduce the ARIS program. And excuse me, ARIS standing for Amateur Radio on the International Space Station. So So the house lights will go down briefly, and we'll proceed here with our first video. Thank you.
Hello, space travelers, and welcome aboard. We're happy to have you join us today as we prepare to put BAMs in space. Today, we hope to highlight our journey by speaking to an astronaut in real time as their orbit passes overhead. Before we get started, let's take a moment to recognize our sponsors for the event. Our primary sponsors for today begins with the Bellefonte Elks Post 1094, a place where neighbors come together, families share meals, and children grow up. The Elks invest in their communities through programs that help children grow up healthy and drug-free, meet the needs of today's veterans, and strive to improve the quality of life. Also sponsoring the event is Reliance Bank. Reliance is uniquely positioned to provide its customers with a special brand of banking while also being an active corporate citizen in the communities they serve. Together we will find a way is the promise they make to all they serve. Amateur radio operators Woody Brem and John Gazar, who encourage all to learn more about the possibilities that amateur radio can bring to your future. And the Nittany Amateur Radio Club, W3YA. This club is very active in emergency services in the area and participates in many public service events within our community and throughout the year. The club also mentors aspiring operators and provides ham radio testing for those interested in the world of amateur radio. Center Communications. With headquarters in Bellefonte, Pennsylvania, Center Communications is your one-stop shop for all your two-way radio needs. Our promise to you is a continued commitment to quality, service, ingenuity, and to personal attention. And finally, AccuWeather. Around the world, people trust AccuWeather to help them get more from their lives. Now then, back to the excitement of our students speaking to an astronaut as they orbit overhead aboard the International Space Station. This is made possible through a collaboration of more than 16 countries and at least 5 distinct space agencies. Our U.S. sponsors include NASA, the American Radio Relay League, and AMSAT US. These groups coordinate to form ARIS, meaning Amateur Radio on the International Space Station. Today, this is a virtual trip via amateur radio.
Anyone assess this is N2SJ, over.
Hi everyone, I'm Cade and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering, and mathematics. Now this is the equipment here in the Columbus Laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus Laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up a ham video too. Just before the predicted time, I begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1, Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board. So I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is, of course, doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
For the past several years, only about 60 schools on the entire planet were selected to make this journey each year. You are here today because the Bellefonte Area Middle School has earned the chance to make this trip. We hope today's event will introduce you to the wireless technologies involved in making this contact possible. And we remind you to dream big and work hard as we move closer to putting BAMs in space.
He has been a meteorologist at AccuWeather for 24 years and has been the head of international forecasting for about 12 years. Prior to AccuWeather, he worked at a couple of smaller weather companies and has been forecasting the weather or has been an operational meteorologist for about 25 years. Next, we have Bill Sarek. He was born in Bristol, Connecticut and has been fascinated by weather that most people would consider bad since he was 5 years old. He was pleased and surprised to find lots of other weather weenies when he came to Penn State in 1980. He received a BS, a Bachelor's of Science, and a Master's in Meteorology, and was then hired by Penn State as a research assistant, again in meteorology. In 1995, he began his tenure as the manager of Penn State's University Park Weather Observatory, now the Joel N. Myers Weather Center. He teaches several meteorology courses and enjoys contact with his students and all others with an interest in the weather. He's been a forecaster on a daily weather show, Weather World, since 2001, and his primary interests are general meteorology and weather forecasting. And last, we have Dr. Christopher Palma. He is an astronomer with an undergraduate degree from Penn State and a PhD from the University of Virginia. He is trained as an observational astronomer and has used many ground-based and space-based telescopes, including the Kitt Peak 4-meter, Cerro Tolo 4-meter, Keck 10-meter, Hubble Space Telescope, and the very large array of radio telescopes. His astronomy research includes studies of the motions of star clusters and dwarf galaxies orbiting the Milky Way, and the gravitational interaction among galaxies. He has taught many different astronomy classes at Penn State, and these days is the head of the undergraduate program in astronomy and astrophysics. He also studies how students learn astronomy and has worked with teachers in State College, Bellefonte, Bald Eagle, and Penn Valley. Welcome to you all. We can have our panel. Please join us on stage. Okay, welcome, gentlemen. We have 10 questions for you. You guys can decide how you'd like to answer them, okay? All right.
So, I'm Colson from 7th grade, and I was wondering if you can see weather patterns in space.
Nice question. Anybody ever watch a nightly weather forecast on TV? Anybody? Okay. It's kind of like that. If you've ever seen a satellite image, yes, basically, if you're high enough up, you can see weather patterns.
Yeah. Like you said, you can see from the space station and from other space vehicles much like a satellite, you can see your tropical cyclones. Actually, if you know what you're looking at, you can actually see thunderstorms and lightning and everything from space as well.
Thank you.
I am Ivan from 6th grade, and have we learned anything new about neutron stars?
That's a great question. Let me say that, unfortunately, when we get questions like this, we often have to say the same thing, which is, so there's a new instrument attached to the space station that's called NICER, and NICER's job is to study these neutron stars, but it takes time. So the instrument was installed just a few months ago, and it's going to be monitoring these neutron stars for a really long time. So what we're going to learn, we expect to learn lots of great things about neutron stars, but it's going to take time for them to take the data, send the data back to Earth, people on Earth to analyze that data and figure out what it means. So my guess is we won't learn something new from that instrument for about a few years now.
Thank you.
Hello, I'm Melina from 8th grade, and I was wondering, how do the materials on the aircrafts, like the metals and wires, how do they resist the temperature changes?
Well, they have to carefully select the materials so that they don't overcome the stresses and the big temperature changes that occur. Anybody here remember the Space Shuttle Challenger? There was a problem with the material. It was a rubber seal to their fuel tanks, and because the temperature got so low before launch, the rubber lost its elasticity and didn't provide a good enough seal for the launch craft when it went up and it exploded. So NASA is very careful to select objects that can put up with those stresses and temperature changes.
I just want to add, so this type of research goes on in a lot of places, including at Penn State. And so some of my friends who have offices right next door to mine, they're going to launch a rocket that's going to go up above the atmosphere and be in space for just a few minutes. They're not allowed to use a lot of materials that we would normally use. And so if you're going to build an instrument for NASA, you're only able to select materials that are what's referred to as have heritage in space. So they've been tested in space, made sure that they can survive in those conditions. And if they have that testing background, then we can trust them and we can put them on new rockets.
Thank you.
Davis Corman, 7th grade. How does the weather affect communication between the ISS and Earth?
Well, for the ground-based antenna and stuff, they would be susceptible to lightning, wind damage, tornado damage, hurricane damage, but I'm sure there's enough redundancies that they could overcome that. Some of the bigger problems would be what they call space weather, where you get solar flares and sunspots that kind of excite the ionosphere and could disrupt radio signals from getting from the Earth out into space.
Yeah, it's kind of neat because everything emits radio waves, and there's a lot of signal between the space station and here, and so they have to direct that signal very carefully. And thick clouds or precipitation can decrease the strength of the signal enough so they can't hear it.
Thank you.
Lydia Wenzel, 6th grade, and what are the requirements to be called a planner?
So, I could probably spend 2 hours just on this question. I will not go for 2 hours. I'll give you the short answer. Words like planet, the original definition of planet included the sun and the moon. So the first time we talked about planets, it was the sun, moon, Mercury, Venus, Mars, Jupiter, Saturn. So Earth wasn't even considered a planet originally. And it just meant an object that moved on the sky differently than the stars. So then we discovered Uranus and Neptune and Pluto, and we called those things Pluto, or we call those things planets, including Pluto, because they move differently than the stars do. But as we've built instruments and we've learned more about these objects, we've learned that they're not all the same. And so Pluto, for example, just looks like a large ice ball, and there's many other large rocky, icy objects like it out in the outer part of the solar system. So honestly, planet, that word, I don't want to stop using it because we've taken a word that was created hundreds of years ago and we're using it in a way that doesn't really work anymore. There was a definition that was come up with in 2006, but I don't like it, so I'm going to go with that one. So I would say a planet is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and any of the 5,000 other objects like them that we found orbiting other stars.
Carla, 8th grade. And is the space station in our atmosphere or in outer space?
Well, depends on the definition of an atmosphere, but most definitions say the Earth's atmosphere goes up about 62 miles. Actually, half the weight of our atmosphere is within the first 3 miles of the ground, so it's kind of, since the space station is higher than 62 miles, then, at least based on that definition, it is in outer space. That's
My name is Gavin Pauly. I'm in 7th grade. My question is, what do stars look like in space?
So when you see a star, has everybody seen stars twinkle? You know, when we say twinkle, the best one to look at is if you go out, if we actually get some clear weather provided by our friends here from meteorology. If you can go look outside on a nice clear night and see the star Sirius. It's the brightest star in the sky, and it twinkles more than any other. And so if you look at Sirius, it'll look white, and it'll change to blue, then it'll change to red, and it'll look like it's kind of winking at you on and off. And that behavior of stars is because the light has to pass through the Earth's atmosphere. So up in space, coming back to the last question, we're up above most of Earth's atmosphere. So if you were in the space station or you were in another vehicle looking out at the stars, you would not see the stars twinkle. So they would appear much steadier. They would just look like a steady brightness. They would not appear to change color. They would appear to have a very steady color. But they wouldn't look otherwise different to us than they do from Earth. They would be little tiny points of light because they're so far away that we can't see them as the real large objects they really are.
Thank you. My name is Cooper, and I'm in 7th grade, and I was wondering if we're ever going to be living on Mars.
all I can say is maybe. Mr. Unbert knows something.
So usually when I get this question, the thing I like to bring up is not so much living on Mars, but getting there. And so I wonder if the astronauts are going to tell you something about this. Space is really dangerous, and it's really bad for people. If you're up in the space station, you're protected as best we can, but when astronauts land back on Earth, they've absorbed so much high energy radiation from the sun that they're at a much higher risk for a lot of diseases than we are. So I met one astronaut, and he mentioned to me that his chance for getting cataracts in his eyes is about 500 times larger than yours will be because of the time he spent in space. And so living on Mars is going to be very tough. We have to figure out, how can we create some kind of habitat for humans, but getting there is even worse. Right? And I hate to sort of take all this enthusiasm and excitement and talk about morbid things, but right now, if we sent an astronaut to Mars, they would arrive dead. So we do not have the technology to get a human safely to Mars. So we can't figure out, we can work on it, but we're not so much working on the living on Mars until we solve the getting there first part.
Thank you.
My name is Sydney. I'm in 6th grade, and I was wondering if astronomers talk to aerospace engineers often.
So I'm an astronomer. I talk to a couple of aerospace engineers from time to time. So let me say, what do astronomers do? We study space. we study the objects in space. And so the way we study the objects in space is often with telescopes or with robotic missions. So we've sent robots to orbit around Jupiter, we've sent robots out to fly by Pluto. Those robots were designed and built by aerospace engineers. But if you say, what were they building? Like, they worked with a team of astronomers who said, I want to study Pluto. Here's what I need on a satellite to collect data that will teach me about Pluto. So it's a team of scientists and engineers working together to define what the questions we want to answer, and then the engineers build the systems that will answer those questions for us.
Thank you.
Hi, my name is Aiden O'Shea. I'm in the 8th grade. And how much does the weather affect the timing of launching a rocket into space?
Good question, Aiden. NASA has something called launch commit criteria that does take weather into effect. Kind of goes back to the Challenger disaster. If the temperature is too low or too high over a certain period of time, they scrub the mission. If the winds are too strong at the launch pad and it's dangerous for the crew that sets up the flight, they scrub the mission. If there's a strong change in wind speed with height, that could cause stresses on the shuttle or on the spacecraft that could cause an accident, they scrub the flight as well. Lightning, rain in the vicinity, clouds that produce ice that will change the aerodynamics of the rocket also can cause that to scrub the mission.
Yeah, and NASA has at least 8 criteria relating to thunderstorms where they can't launch. You have to have lightning. Lightning can be within a certain distance because, like the Apollo 12 rocket, when it was launched, it actually got struck by lightning on its ascent. But the crew was able to reset the instrument panels in enough time so they could safely make it into space. And alluding to what he said with the Challenger explosion, the O-rings had some problems because of the extreme cold and it iced up, but actually what happened, if you look at some of the video, as the rocket was going up, aluminum oxide kind of helped seal that initially, but then it encountered some extremely strong wind shear, which is a change in wind direction or wind speed as you go higher up in the atmosphere, and it jostled the connection enough that even the temporary seal that the aluminum oxide made got broken up and allowed the flames catch up, and that eventually led to the explosion. But without that wind shear, there's a possibility that the Challenger could have made it even with the O-ring failure. But so there's a lot of criteria that can go in, and like I said, with ice, they don't like to launch rockets through clouds because of, especially if they're go below freezing temperatures, because ice can have detrimental impacts on the rocket as well.
That wraps up our questions from our students. Do you have any final comments that you'd like to share with our school before we move on to the next portion?
Is there anybody here who really gets excited by bad weather? Big snowstorm? Okay.
No days, maybe.
Lots of
About
days.
delays.
So if you want to go into science, what course do you think you should work the hardest on in middle of high school? Just yell it out. What do you think? Science is fun. There's one word. There's a lot of math. So challenge yourselves in school. Set yourselves a goal.
There is a test today. I don't know if your teachers told me that. So, anyways, just real quickly with a show of hands, how many of you are in the Bellefonte Middle School? Okay, so students, now keep your hands up. Students, I want you to pay close attention. All the adults in the room forgot that they're in the middle school today. Okay? All right. So, now that we have that out of the way, I think everybody that's here should really be here, right? Okay. Next show of hands, how many people were involved in this project either through learning in the curriculum or in extracurricular things, either building parts for the antenna systems or being involved in some other way. Show of hands, how many people were directly involved in this in some way? Learning in your classrooms? Come on, I know you were in there.
I think just about every science classroom talked about something, maybe your English classes.
This next video will highlight some of that. So again, when the house lights go down, we'll start the video. But just a short 3-minute video, and it focuses on the participation and preparations that all of you put into making this event possible. So here we go. the Meet Your Astronaut series. And the astronaut, as you know, will be Mr. Scott Tingle, who will be speaking with today, or at least trying. And this is about an 8-minute video of his journey into space. Very much condensed. It takes several days for this to happen. But it'll begin with his launch off of the pad in Kazakhstan, and end up with him arriving into the International Space Station. So this will be our last video.
With that, we see the fires lit, the engines start to roar, and lift off. Scott Tingle and Josh Gavlaroff and Nora Sheedy unite on their way to the International Space Station.
Just about 10 meters separating the Soyuz and the station. Closing in, standing by for contact and capture of the International Space Station. Contact confirmed. Capture confirmed. At 2:39 a.m. Central Time, 3:39 a.m. Eastern Time. And the Soyuz hatch now swings open at 1:55 p.m. Moscow time, and Scott Tingle of NASA makes his way to the International Space Station for the first time. The United States, the American people, let me just tell you all how delighted we are and how pleased I am to be able to congratulate you on this momentous occasion with Mission 54. I have to say, we've got three great Americans, we've got friends from Russia, we've got a great friend from Japan who are part of this mission, and it's such an honor to the Marine Corps, little Army, and I have to tell Captain Tingle that I was watching the faces of his family members as that hatch opened and it brought a tear to my eye. It was the most special thing being here and feeling the emotion. Everyone is so proud of you. We congratulate you on what you're doing, not just for the people of Russia, the United States, and Japan, but for the people of the world. Congratulations. Thank you, Rob. Thanks a ton. That's incredible.
It's obviously exploring new and distant places. And at first, that's when we were younger, that's what I wanted to do. I saw Neil Armstrong walk on the moon, and I looked at my mom and said, hey, I want to do that. I had to create my own opportunities. And so when I got my first job, I was 9 years old, and then I was working pretty much full-time by the time I was 14. If I wanted a bicycle, I had to go find the parts and put it together and make it work right. So I did that. Not only was it a good bicycle, but it was the best bicycle in the neighborhood. It could ride wheelies, and it could go over jumps, and ride through the woods. And I did everything on that. I graduated high school from Blue Hills Regional Vocational Technical High School, just south of Boston, Massachusetts. Really good experience there, working with a lot of machines and technical design and things like that. Got a lot of after-school jobs doing technical things, so it was a really good experience. Moved on into engineering at Southeastern Massachusetts University, now called University of Massachusetts. They changed over in mechanical engineering. Again, another great opportunity. Had some great mentors there, folks that I still keep in touch with to this day, professors, deans, all those folks, presidents, all those folks that run the school. Just a great facility and great people. And then moved on to Purdue University, again in mechanical engineering with a specialty in fluid mechanics and propulsion. Clean bakery at night between midnight and 6 in the morning. I was just getting into high school, and then graduated that opportunity to actually making bagels and bread and things like that. And all of that funded my first year or two of college, and without which I would not have gone. So at a young age, I realized that if I wanted to get somewhere, if I wanted to get to be an astronaut, I was going to have to start working early and hard to make it happen. In college, we got a very tight engineering group, and it was so tight that we started pulling people in from other disciplines, computer science, business and things like that. And the camaraderie was absolutely incredible, and the support that we gave each other was absolutely incredible. I did a little bit of Kung Fu for about 3 years there because it was active, it was physical, and it was something different that I wanted to try. I was in a rock band, played lead guitar all the way through college. We had several gigs in and out of Boston, Providence, up and down the East Coast there a little bit. And that was actually a pretty good team activity too. I actually enlisted when I was 18 years old, and I spent my summers going to training in Chicago and Japan and some other places where my unit deployed. And then I did 1 to 2 weekends a month. Every Navy squadron, Air Force squadron, they have names. We have 14 squadrons, Charlie Roger, the Tom Adams. Those are all F-18 squadrons. I'm not aware of the F-14. But the VX-9, they call themselves Empire, just because that's just what they were. We did a lot of testing of systems and vehicles at night for missions that no one can see. I want to see what's over the horizon. I want to see new places. I want to meet new people. I want to create new technology. I want to be part of the future. I want to have an impact on the future.
I've had the opportunity to do a lot of great things in the 30-year career, engineering, flying airplanes, and now here with NASA. And the groups of people that I've worked with have been absolutely incredible. Well, the one consistency across the board is that they have provided me with a lifetime of inspiration. So I grew up in a town of Randolph, Massachusetts, kind of a small town, and the folks at home knew how driven I was. They knew how interested in science, engineering, and space flight I was, and they were nothing but supportive the whole way. There's literally thousands of people that I've worked with in my military career. Absolutely unbelievable. Some of the most inspirational young Americans you'd ever meet in your life. You'll walk down in the bowels of the ship, and you'll see these 18, 19, 20-year-olds covered head to toe in grease, just coming off a 24-hour shift so that we could fly our airplanes safely and efficiently. Absolutely inspirational. When things get hard for me or challenging, I think of those folks, and it makes me want to do better. And that's one of the things that I'm finding is very consistent throughout my career. When I came here, we've got civil servants, we've got contractors, we've got military, you name it. And we all have one goal, one mission. And watching the team work together is just inspiring. My ultimate inspiration is the love and support I get from my family. They've been so solid over the years. There's absolutely no way I could be doing all this without their support. I'm Scott Tingle, and I'm a NASA astronaut.
Okay, thank you everybody. We'll just take a few minutes here to get the stage ready with the amateur radio team coming up. And you all can stay seated for a moment until we get a little bit closer. We'll have some time to fill in here. So a little stage change and we'll be right with you. So now's the time to talk and get it out of your system if you need to do that. With today, and you saw in the videos, Mr. Scott Tingle. And the center screen probably needs a little bit of an explanation. So I'm assuming that you all are up to speed on your geometry, or geography. And you see the North American continent there in the United States. And you see that shaded gray circle that's coming across the United States right now? The plus sign in the center of that circle is the International Space Station. And that circle represents the horizon at which point the space station will be visible. So, the plus sign over there about where Pennsylvania would be, that's our location here where the antenna is located on top of this roof. When the gray area reaches the edge of that plus sign where Pennsylvania and the Bellefonte Middle School is, at that point we should start calling the space station and hopefully hear them in return. Down at the bottom of the screen, you see from right to left, there's a 63, and a little further in it says AOS, and it shows 4 minutes. That means that in about 4 minutes, we will have acquisition of signal and should be able to communicate with the space station. So those are the things we're going to want to acknowledge. contact, we'll try from both directions, and until we can establish that we do have an active two-way link to the space station. And then at that time, Woody will turn it over to the first student, and we'll begin our questions. So,
During this time, it is incredibly important that there is no talking, just as we talked about this morning. There's no talking while we're in this portion of the program. Think about how big of a deal this is that we are about to talk to an astronaut on the International Space Station. We need to make sure our radio crew over there can hear everything they need to hear. So we have 15 questions and only 9 minutes to do this. So very little window to make sure we get in all of our questions. So please make sure you are not talking to your neighbors throughout this event.
thank you, Mrs. Garvin. Okay, so you see it's at 0. Now we're waiting for the elevation. Because we live in the valley, where the space station is coming up here to the north, we have to have them at an elevation of about 1.5 degrees above level before we can get them above the mountain and communicate. So right now we're at 0.2 of a degree and climbing. There you see their horizon is just touching the Bellefonte Middle School. And we have squelch and audio there from the 746. Okay, there's 1.2 degrees, so let's give it a try.
NA1SS, this is Whiskey 3, Yankee Alpha. NA1SS, this is W3YA. NA1SS, this is W3YA. Roger, Roger, we got you 5 by 3, 5 by 3 Bellefonte. NA1SS, this is W3YA. NA1SS from W3YA. NA1SS from W3YA.
Whiskey 3, Yankee Alpha, the November Alpha, 1 Sierra Sierra on channel 40. How copy?
All right, Scott, we copy you 5 by 9, full quieting at Bellefonte. Good afternoon. NA1SS. NA1SS from Whiskey 3, Yankee Alpha. NA1SS from W3YA, we copy you 5 by 9, Bellefonte. All right, please proceed.
I am asking this question on behalf of Sam, 8th grade. Is there a specific task that astronauts have to relearn how to do because the normal way is impossible with zero gravity?
We have to relearn how to do in space.
This is Nash, 7th grade. How many more years will the International Space Station be active to help astronauts find out about space?
And Bellefonte Area Middle School, that last question did not come through. Please repeat.
This is Nash, 7th grade. How many more years will the International Space Station be active to help astronauts find out about space?
Bellefonte Area Middle School, it appears that something may be wrong with your microphone. I can see that I am receiving a signal, but there is no side tone and no voice. And Whiskey 3, Yankee Alpha, November Alpha 1, Sierra Sierra on channel 40. I am no longer receiving a Bellefonte Area Middle School. I see good bars on my receive, but no voice.
So it appears he can see that we have a signal going up, but for some reason he can't hear that signal. So we're not sure at this point. It appears that everything's working fine here, and there might be a problem up there. So bear with us. We'll do the best we can for the time we have left.
Whiskey 3, Yankee Alpha, November Alpha 1, Sierra Sierra International Space Station on channel 40 in the Pine. I do not hear any voice coming from your signal.
NY-SS from W3YA. NY-SS from W3YA. Alrighty,
Okay, well, as you can see from the map, there were a few technical difficulties in this space. Okay, so they're beyond the horizon. So, to all you students that are still up here, this is space, this is the unknown, so we did have to roll with the punches. I'm very sorry that it worked out that way. So have a good spirit, and thank you very much. All right, let's have a big round for this. As they passed overhead for several other school contacts, but today seems like the dice were stacked against us. But we did get here Mr. Tingle from space, and that's pretty exciting. So a big round of applause for Mr. Tingle. Mrs. Garvin, I think she has a few words to say, and let's have a big round of applause one more time for